Assalamualaikum warahmatullahi wabarakatuh and a very good day, class. Let's start our asynchronous video straight away. Thank you for watching this video. Well, as you can see in your display is the three type of test that is concerned in our syllabus, which is test with AC voltage, test with high voltage, test with DC voltage, and high voltage test with impulse voltage. So for today, we're going to cover this AC and DC. As you can see, the 6 clauses 6.1, 6.2, 6.3, 6.5, and 6.6 is basically the same for both of them. And the one is that is different in this clause 6 and 7 is the test procedures. So let's have a look at the test procedures, the difference between AC and DC, all the similarities as you can see. Then in the next video, we'll go through the impulse voltage. Well, this is the one that is different between those three. AC, DC, and impulse. The procedures. Well, between AC and DC, the procedure for 6.4.1 and 6.7.4.1, 6.42.4.2, and 7.4.2 is about the same. Even 6.4.3 and 7.4.3 is about the same, whereby the first one is a withstand voltage test. You have to control how you raise the voltage, and then you must apply the voltage to the insulation, and it will be in a period of 60 seconds. Okay, if it doesn't discharge during the 60 seconds, it means that it can withstand the voltage, right? So first is withstand voltage test. You inject a voltage, either DC or AC, and then you see in 60 seconds or in 5 minutes, according to the standard that you refer to, okay, according to the product standard, which means for product, the cable standard, the transformer standard, the switchgear standard that you refer to, the time it has to withstand differs. Okay, so first 6.4.1 is withstand voltage test. 6.4.2 is, while 6.4.2 is disruptive discharge voltage test, right? And in this test, the idea is to inject the voltage for a certain period of time as well and see whether the insulation breaks down on that particular voltage. Okay, so it's here, it is written in disruptive discharge voltage test. The test voltage is raised as withstand test until a disruptive discharge occurs, which means until it breaks down. Okay, and further, I wrote here detailed procedure of how many times the withstand test to be applied and which voltage to be recorded depends on the relevant UUT standard. Again, depends on the transformer standard, testing standard, of cable standard, testing standard, right? And some statistical evaluation is required to give a probabilistic spread of the disruptive discharge voltage. So when you do this test, you need to come up with the result, such as what is the disruptive discharge voltage. So to determine that voltage, you will have to refer to clause 15. And then we will spend some time to exactly check on this clause 15 later, okay, when we go to the lightning impulse, right? But for now, just take note that disruptive discharge voltage, we have to define at what voltage it breaks down. So how? Okay, and then the third one, if you look below, assured disruptive discharge voltage test. Well, make sure you understand the sentence here. 6.4.3 says that at this voltage, for sure, it will break down. Okay, that is what it is meant by assured disruptive discharge voltage test here. The voltage shall be applied and raised just as the withstand test until a disruptive discharge occurs on the test object. It looks like 6.4.2 as well. However, be patient. The value of the test voltage raised just prior to the disruptive voltage discharge shall be recorded. Let's say it breaks down at 10 kV. And the voltage you test below 10 kV is 9.9 kV. So therefore, we will record 9.9 kV as the assured disruptive discharge voltage test, which means if you apply 9.9 kV above, for sure it will break down. So this is basically the three different types of tests for AC and for DC. Make sure you're clear about that. One is withstand test. Second is disruptive discharge voltage test. And the third one is assured disruptive discharge voltage test. The first one is if it can withstand the given voltage, if the insulation can withstand the given voltage for 60 seconds. The second one, the 6.4.2, is the voltage at which causes the insulation to break down, while number 6.4.3 is the voltage which you are sure that if you apply, breakdown will occur. So it looks a bit confusing from my explanation, but let's use ChatGPT in this case. So now you see, I asked ChatGPT, what is the difference between withstand voltage test, disruptive voltage discharge test, and assured disruptive voltage discharge in IEEE standard 4. So therefore, this is the answer. Okay. Withstand, okay, they each apply different voltage levels and testing criteria to assess the insulation integrity. So basically, that's it. All the test involved in standard IEEE standard 4 is to test the main purpose is to test the insulation integrity. So this is how they differ between themselves. Withstand voltage test to confirm that insulation can withstand a specific voltage, either AC or DC. Again, the pass-fail criteria, whether it can withstand the voltage for the entire test duration without any flashover, breakdown, or other disruptive voltage. So you're clear about that. Applications commonly used for routine testing to verify insulation reliability in normal operation conditions. So what's routine testing? Well, ask me in class. So key characteristics, this withstand test is non-destructive. The goal is to ensure the equipment can handle the applied voltage without damage. Specified duration, usually 1 minute. Now, disruptive voltage, discharge voltage test. What's the purpose? To determine the voltage level at which insulation breaks down. The approach, voltage is increased gradually until it reaches a point where a disruptive discharge breakdown occurs. What's the pass-fail criteria? The voltage at which breakdown occurs is recorded and the insulation does not pass if a breakdown happens at the voltage below design expectations. So clearly this is a type test because you are testing a prototype, design stage. Applications used in research, development, or acceptance testing. Just now for routine testing is a non-destructive type for withstand test, but now for disruptive discharge voltage test is a destructive test and it's used for acceptance testing. See here this keyword, acceptance testing. Key characteristic, destructive test. The purpose is to force insulation failure. You force the failure, then you establish what is the voltage, threshold voltage. Okay. Number 3 is just now it was disruptive discharge voltage test. Now it's assured disruptive discharge test. Now look at the purpose. It wants to tell you for sure it will discharge at this voltage. So the purpose is to validate that the insulation can withstand a disruptive discharge at a specified voltage level, which is deliberately designed to cause breakdown. It is purposely designed to cause breakdown, such as spark gaps for discharge tube, gas discharge tube. Okay. Okay, test approach. The equipment is subjected to a voltage known to cause disruptive discharges, and the discharge characteristics are assessed. The pass-fail criteria, the test pass if the discharge occurs as expected without adverse effects beyond the intended breakdown, which means it doesn't break down much earlier, something like that. Applications test specifically used in specific reliability testing or quality control to confirm consistent breakdown behavior and safety. The key characteristic, control disruptive event. This test is intentionally designed to initiate a breakdown at a set voltage. Focus on reliability of response. Ensures equipment installation will perform consistently under conditions where breakdown is expected or allowed. So for test number 3, the type is you want it to break down. You want the insulation to break down. For number 2, you don't want the insulation to break down, but you want to know how high a voltage it can withstand before it breaks down, exactly before it breaks down. While test number 1 is for you, excuse me, is for you to actually see whether can it withstand or not. So test number 1 is non-destructive. The product or the unit and test can still be used after the test. That's why it's used for routine testing. Product number 2 is destructive. Sorry, no. Test number 2 is destructive, and also is test number 3 destructive. So therefore, they are used at the design stage usually. So I'll give you a table. ChatGPT is better, a very good student. I asked them what the differences and the similarities, and they give us a table. So we can use this table for reference to really understand the differences between withstand voltage test, 6.4.1, 6.5, 7.4.1, 8.4.1, and the difference between disruptive discharge test, discharge voltage test. This is they want to know at what voltage it breaks down, and the difference with a sure disruptive discharge test. In this test, we are trying to say that for sure at this voltage, this insulation will break down. So each test targets a different aspect of insulation performance. Withstand test ensure resilience, the word resilience at operating voltages. Disruptive discharge test establish breakdown limits, and assure discharge test validate consistent failure behavior at the control voltage. So this sort of summarize all the three, and which I see can be used as a start for further assessing the types of tests in impulse voltage stresses. Okay, we have done the AC stress and DC stress. We know the type of differences. We know the type of requirements of the voltages to be set for the test. Now later we can focus on impulse. So impulse, make sure you revise the type of impulse that we test on products, on high voltage insulation, which is only divided into two, is either switching surges or lightning surges. So with that, I wish you all the best before we meet next time on another video. So with this video, I end this video with this ChatGPT summary for us, and I will share the link as well for this ChatGPT result. And in the link, you will see that when I ask ChatGPT using numbers, ChatGPT is giving me a false answer. So the second question in the link of this ChatGPT, the answer is false. So don't rely on the answer from that ChatGPT. So with that, thank you very much. See that this video is indeed less than 15 minutes, but even though it's less than 15 minutes, it is explaining quite critical part on this high voltage test, which is the difference between the three tests that is usually done on insulation. So the first one is for routine tests. The second one is for acceptance test for prototypes, while the third one is for where you need a condition where breakdown is wanted. You want the breakdown to happen. Okay, so those are the three different characteristics between the three tests. And with that, I thank you very much. 14 minutes you spend time with me. Hopefully it will be better next time. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye-bye.